Today we are looking at statistics. Statistics is the collecting of data, the organizing of data, and the analysis of data. We're going to focus on just organizing data today, and we're going to organize our data using something called a stem and leaf plot. Now, what's special about a stem and leaf plot is that it organizes the data by the place value position of the data numbers. So to begin with, we have to have a data set. So here I have a data set. Now, the first thing that I always think about when I'm working in statistics is it's easiest if we order our data sets from smallest to largest. And with stem and leaf plots, it's easiest for us to do that because it really starts to set up our actual data display. Now, the stem is all the numbers that are not the ones place. The leaf is always the ones place. So if we take a look at the number 27, the 2 goes in the stem and the 7 goes in the leaf because we always have the leaf as a ones place. So what I do is I go through my data set and I take a look at my stems and I see 20, 50, 40, 60, and 30. So there I know that I'm going to have a 2, 3, 4, 5, and 6 as my stem. Now remember, it doesn't represent 2, it represents 20, and it represents 30 and 40. So then, because I've organized my data from smallest to largest, I have to organize my leaves. Now that's the point of this. It's the organizing of the data. That's part of what statistics is. So my leaves should always be going from smallest to largest. And when I look at this, I know I have 21, 27, 29. Then I go 31, 33, 40, 40, 41, 44, 46, 56, 56, 58, 60, and 62. So I'm just organizing that data. Now, I always go and I recount my data to make sure I have everything. So I have 2, 4, 6, 8, 10, 12, 14, 15 pieces of data. I have 2, 4, 6, 8, 10, 12, 14, 15 pieces of data. Then I know that I've got all my data pieces. Now, how does this help us? Well, number one, we can take a look and we can see some of our landmarks. So when I'm talking about landmarks, those are those key figures that we use in statistics. So some examples of them are the minimum, the maximum, the mode, the median, and the range. And I can see all of those landmarks through this stem and leaf. So let's start with the minimum. It's just the smallest number. Well, we can see that's going to be the 21, which is my first number in my stem and leaf. My maximum is my largest piece of data, and that's going to be the last number in my data set. So you can already see how this organization is helping me. Now my mode, that's the most frequently occurring pieces of data. And I actually have 2 modes today because I see a 40 and a 40 and I see a 56 and a 56. Those are the most frequently occurring. So I would say my modes are 40 and 56 because I have them twice. My range is my largest piece of data minus my smallest piece of data. So it's my maximum minus my minimum. It's the spread of the data from the smallest number to the largest number. Well, when I subtract 62 minus 21, I see that the spread of my data is 41 for that. Now the median we can find. It takes a little bit of work, but we know the median is that middle number. So if you put your fingers on both ends and you start to work your way in from smallest to largest, some kids would say, oh, the median's 1, but remember, you have to put it back with the stem. So the very middle piece of data, the exact center of my data set, would be the number 41. Now, we don't always have just 2-digit numbers in a stem and leaf plot. And so what's crucial for us is we actually have to create a key. It tells us how to read those numbers. So when I see my key, I see 2, then I see a line and 1. That line represents that split between the stem and the leaf. And so it says when I have a single number in my stem and a single number in my leaf, I can put it together as a number 21. But what if I had a decimal? Well, I can do my decimals as well, but remember, the key part, the leaf can only be 1 digit. So if I have this decimal, my stems become 2 digits. and I still do them in order from top to bottom. So even though this is 2 and 6800ths, I write 26, and this is 3 and 2300ths, I write 32. Now, the key is the crucial piece, because when I look at the key, I see 26, a solid line 8, and I said that equals 2 and 6800ths. So you can have as many or long numbers as you want, as long as only the ones place goes in the leaf and then all other numbers go in the stem. But that key has to be there, otherwise we don't necessarily know how to read the number. So there's my stem and leaf plots. Now, from a stem and leaf plot, I can create what's called a histogram. And the histograms, what we do is we go first and make a frequency table, and it's really a tally chart of what we see. And so I create intervals with this. So I see that I have 20s, 30s, 40s, 50s, and 60s. So I created an interval of 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. It's representing this data set. Then I go and I tally how many digits or pieces of data actually were in that interval range. Well, I had 1, 2, 3 in my 20s. I had 1, 2 in my 30s. I had 1, 2, 3, 4, 5 in my 40s. And remember, when you're doing tallies, you can put the 4 tick marks and then a line diagonally across. I have 3 in my 50s and I have 2 in my 60s. So then to get the frequency, we turn the tally chart into numbers. And so I'm just saying my tally was 3, my tally was 2, my tally was 5, my tally was 3, my tally was 2. From there, I create what's called a histogram. Now, a histogram looks an awful lot like a bar graph, but it is not. You'll see some changes or differences here. Number one, on bar graphs, we usually have spaces between the bars. Histograms, you never do. And the reason why is because a histogram is made up of 2 number lines. I have a number line across the bottom and a number line across the top. Bar graphs usually have categories on the bottom, like favorite ice creams would be vanilla, chocolate, strawberry. So you'll often see words here on a bar graph, whereas a histogram, it has to be numbers on both of these axes. Now, what we're doing is we're creating the bars and it's showing the spread of the data. So if I have my 20 to 29, I went up on an interval by tens. Well, remember, I had no numbers from 0 to 10. I had no numbers from 10 to 20. My data set started at 20. And so how many pieces of data did I have at 20? Well, that's this side, that's the frequency. It's how many times did it happen? Well, it happened 3 times. So my bar goes to the 3 to represent that 3 times. And then from 30 to 40, I had 2. From 40 to 50, I had 5. From 50 to 60, I had 3. And from 60 to 70, I had 2. So we're simply taking our data set and we're creating bars to reflect how many times those pieces of data happened. And it's within the range or the interval. So we can take any stem and leaf plot, which organizes our data, and we can then organize it in a frequency table, and then we can then organize it in a histogram. Now, we would use these for different reasons. This is a little bit harder to see my maximum, my minimum, all of my landmarks here. This is more just to show me what frequency did it happen the most. Between 40 and 50, that's where most of my data is. So your job today is to work on organizing data using stem and leaf plots, frequency tables, and histograms. So it's a part of statistics that's really important for us. Good luck, I know you'll do well.